From standard form to vertex form, completing the square. Our learning goal today is to use the complete the square technique to convert the standard form to vertex form of a quadratic expression. Please ensure you have the lesson printout so you can follow along with this video. Recall converting the following equation from vertex to standard form. Here we have y is equal to 2, bracket x plus 3 squared minus 5. Do you remember how to convert this into standard form? First, we have to expand this bracket. So we'll leave the 2 out in front, and we're just going to rewrite the bracket in its expanded form. X plus 3 times x plus 3, and we still have the minus 5 out here. And then we're going to FOIL what's inside the bracket. So we can do first, which is x squared, outer, inner, and then last. And then we're going to simplify what's in the bracket by adding what's in the center here. So we have two like terms, the 3x and the 3x. So we're just going to add those together. And then we have to rainbow this 2 into everything inside this bracket now. So y is equal to 2x squared plus 12x plus 18 minus 5. The last thing to do is to put these two like terms together. So let's bring that up here. We'll have y is equal to 2x squared plus 12x and 18 minus 5, that's 13. Okay, so here we have our standard form, and what we had to do here was expand and simplify to standard form. To convert from standard form to vertex form, we need to use a process called completing the square. Notice that in vertex form, we always have the part that looks like this, or this. This special product is called a perfect square. And we've dealt with perfect squares before when we were learning the different techniques of factoring. When expanding, we'll use this example here. X plus h squared looks like this. And it's always going to follow a pattern. X squared plus 2 times x times h plus h squared. This is always a perfect square trinomial. We're going to use this property and work backwards to convert from standard to vertex form. Let's see what this looks like in practice, and let's see if we can understand a pattern that comes from this. Okay, so let's try to solve this. We know x plus 4 squared just means x plus 4 times x plus 4. And so let's go ahead and FOIL this. So we get x times x, which is x squared. We're going to get 4x plus 4x, and then 4 times 4 is 16. Now let's simplify that. We're going to get x squared plus 8x plus 16. Now let's try x plus 3 squared. That just means x plus 3 times x plus 3. And if we do that, x times x, which is x squared, plus 3x plus 3x. 3 times 3 is 9. And then let's simplify that. We're going to get x squared plus 6x plus 9. Let's examine these equations closely to see if we see any patterns we could recognize. Take a look at the B and the C pattern, here and here. How are they related? If we took half the B value and squared it, we can get to our C value. Let's see how this works. So if we took half of B here, which is 8, and divided it by 2 and squared it, 8 divided by 2, we know that's 4, and 4 squared is equal to 16, our C value. Likewise, if we did that over here, we would get half of 6, so let's do that. 6 divided by 2 squared. So 6 divided by 2 is 3, and 3 squared is equal to 9. Now that we know the technique to solve the C value in a perfect square trinomial from the B value, let's practice making some perfect square trinomials. Determine the value of C that will create a perfect square trinomial. Verify it by factoring the trinomial you created. Okay, so we know in a perfect square trinomial, the C value is half the B value squared. So let's try it here and see if it works all the time. So in this case, B is negative 14. So let's plug it into here. So negative 14 divided by 2 and squaring it. So negative 14 divided by 2 is negative 7, and negative 7 squared is equal to 49. So if we're going to write this whole perfect square trinomial out, it would look like this. X squared minus 14x plus 49. Let's try factoring this. Can you think of two numbers that multiply to positive 49 but add up to negative 14? That's right, negative 7 and negative 7. So the factor brackets would look like this. And another way to write this is x minus 7 squared. Let's try example C. Okay, so we're going to follow the same pattern. To find C for a perfect square trinomial, we need half the B value and we need to square it. In this case, half the B value would be 40 divided by 2, and we're going to square that. So 40 divided by 2 is going to be 20 squared, and 20 squared is equal to 400. So if we're going to write this out as a full perfect square trinomial, we'll get x squared plus 40x plus 400. Can you think of two numbers that multiply to 400 but add up to 40? Great work. X plus 20 and x plus 20. And this can be rewritten like this, x plus 20 squared. And for our last example here, we're going to follow the same pattern. So half the B value in this case is going to be 20 divided by 2. And we've got to square that as well. So 20 divided by 2 is 10. And 10 squared is 100. So we know what our C value is. So it's going to be x squared plus 20x plus 100. Okay. And can you think of two numbers that multiply to 100 but add up to 20? That's right, 10 and 10. So it's going to be x plus 10 and x plus 10 for our factor brackets. And we could reduce that to x plus 10 squared. So now we know how to make perfect square trinomials. And this is going to allow us to solve from standard form to vertex form. Now, we've done standard form to vertex form before in our last unit, but it required us to first factor our standard form expression and then find the zeros and then plug it in to find the vertex and all that. So there's a lot of different steps. So we're going to learn another technique that can help us go from standard form to vertex form. So let's try the completing the square technique. Now, just a warning, it can be a little bit confusing, but if you follow the steps and practice, you'll be fine. Let's try it out. Convert the following from standard to vertex form. So the first thing we want to do is ensure that x is all alone, nothing in front of it. Okay, so here we have nothing in front of the x. You may have to factor out the first two terms to do so. In this case, we don't. Because x squared is by itself already, we can go straight to step 2. Step 2 states we should add half of b squared and subtract half of b squared after the b value. Here b is 6. So half of b squared is going to be 6 divided by 2 squared, which is equal to 3 squared, which is equal to 9. So now we're going to write our equation again. And we're going to add and subtract 9. If you think about it, we're not really adding or subtracting anything because plus 9 and minus 9 is just 0. So we're not changing the equation at all. But this allows us to do something. If we add brackets around the first 3 terms here, we'll notice that this is a perfect square trinomial, and so we could factor it as such. And we really can jump straight to our binomial that's squared. So we just have to think of 2 numbers that add up to 6 but multiply to 9, and that's going to be x plus 3 and x plus 3. So we can just jump to x plus 3 squared. We still have the negative 9 on the outside and the negative 1. So now all we have to do now is step 4. We add like terms together to simplify. Here we have negative 9 and negative 1, and that's going to be equal to negative 10. Okay, so we really haven't changed the values within this equation, but we were able to convert from standard form to vertex form. So this is the vertex form of the equation. Y is equal to x squared plus 6x plus 1. Let's try another example. So here we have y is equal to 12x plus 22. So let's complete the square. So half of b here would be 12 divided by 2, and then we'd have to square it. 12 divided by 2 is 6, and 6 squared is 36. So we're going to write out our formula. Y is equal to x squared plus 12x plus 36 minus 36 and plus 22. And now we'll put brackets around the first 3 terms, and we'll recognize that this is a perfect square trinomial. To factor this, we just have to think of 2 numbers that add up to 12 but multiply to 36. And those 2 numbers are going to be 6 and 6. So we can go straight to our binomial bracket here that's squared, which is going to be x plus 6 squared. And we still have the 36 on the outside and the 22 that's out there, and we're just going to add these two together. So we're going to get y is equal to x plus 6 squared, and negative 36 plus 22 is going to be negative 14. So you can see how simple it is to go from standard form to vertex form using this completing the square technique. It saves us a lot of time from having to factor, finding the midpoint, plugging it back in, then finding the vertex. We can go straight to the vertex form using this technique. So let's try an example where there's a coefficient in front of the x squared. Here it says, ensure that x squared is all alone and nothing in front. You may have to factor the first two terms to do so. So let's do that. Let's factor these first two terms here. So all we want to do is just factor out the 2, so we have our x squared by itself. So now x squared is all by itself. Now we can go on to step 2. We have to add half of b squared and subtract half of b squared to the b value. In this case, our b is negative 8, so we need to do negative 8 divided by 2, and we need to square it. And if we simplify that, it's going to be negative 4 squared, and negative 4 squared is positive 16. Okay, so we're going to rewrite this. Y is equal to 2. We still have our bracket here. X squared minus 8x plus 16, and then minus 16. Then we're going to close our brackets and have our plus 12 on the outside here. Now we need to factor the first three terms within this bracket. So what I like to do is add another bracket in here. And you'll notice again that this is a perfect square trinomial inside, so we can factor it to the binomial. So we just have to think of two numbers that add up to negative 4 but multiply to positive 16, and that's going to be 4 and 4. Or negative 4, negative 4. The b is negative. So we're going to get within our square brackets here x minus 4 squared, but we still have the 2 on the outside, and we still have this negative 16 within this bracket here. So this new step here says step 4, multiply the coefficient a in front of x squared to the unfactored b divided by 2 squared. So we have to multiply this 2 into the 16 before we finish off. And so we're going to get y is equal to 2. And what we'll do is we'll keep the bracket here, x minus 4 squared, and 2 times negative 16 is negative 32 plus 12. So once we do that, we can get rid of the bracket, and we're going to get something that looks like this. And so we just have to add these two like terms to finish this off. Y is equal to 2 bracket x minus 4 squared, and negative 32 plus 12 is going to be negative 20. So here we are in vertex form. So it's a little bit complicated, but again, if you practice these steps, it should be not too bad. Let's try another example. Here we can see that the x squared term isn't by itself. There's a negative in front of it. The first thing we need to do, in this case, is factor out these first two terms of this negative term. So we're going to get y is equal to negative 1 because we're going to factor it out. And then we're going to have x squared minus 10x within this bracket for the first two terms. Now we can go to step 2. So we have to add half of b squared and subtract half of b squared. So let's figure out what half of b squared is. In this case, our b value is negative 10. So negative 10 divided by 2 squared is going to be equal to negative 5 squared, which is equal to positive 25. And so we can write that in right after the b value. So we're going to get x squared minus 10x. Then we're going to add half b squared, subtract half b squared, and we'll have the negative 7 on the outside. Next, we're going to add brackets to the first three terms within this bracket and factor these, and we should notice a perfect square trinomial within this. So we have to think of two numbers that multiply to positive 25 but add up to negative 10, and of course it's going to be negative 5 and negative 5. So we're going to get x minus 5 squared. So this is just as red brackets factored. We still have this blue bracket here with the negative 25 on the outside and the negative 7 outside of that. And so step 4 says multiply the coefficient a in front of the x squared to the unfactored half b squared. So this negative 1 has to multiply to this negative 25. So we're going to get y is equal to negative 1 bracket x minus 5. And when we multiply it through, we can get rid of this bracket here. So we're going to get plus 25. So negative 1 times that negative 25 is going to be plus 25 minus 7. And so let's finish this off. I'll just move everything over here. We're going to get y is equal to negative 1 bracket x minus 5 squared. And then we have positive 25 minus 7. And that is plus 18. And there we are in vertex form for this equation. Let's solve a word problem which can be solved using the completing the square technique. Carly has just opened her own nail salon. Based on her experience, she knows that her daily profit P in dollars can be modeled by the relation P is equal to negative 15x squared plus 240x minus 640, where x is the number of clients per day. How many clients should she book each day to maximize her profits? Here we can see the question's asking for a maximum. And we want to find the x value that would give us our maximum. So it would be easiest to turn this into vertex form and solve what our maximum would be. And using the completing the square technique, we can do that. So let's begin. So we have our equation here. P is equal to negative 15x squared plus 240x minus 640. And so the first thing we notice here is that the x squared value is not by itself. So we want to get it by itself. So let's factor these first two terms here. And if we do that, we factor out a negative 15, we'll be left with x squared. And 240 divided by 15 is going to be negative 16x. And we still have the negative 640 on the outside here. The next thing we need to do, since we have x by itself, is add half b squared and subtract half b squared within this bracket. So the half b squared in this case would be negative 16 divided by 2 squared, which is equal to negative 8 squared, which is equal to 64. And so we can add and subtract that value from within the bracket. We'll have x squared minus 16x still and then we'll have plus 64, and then minus 64, and we'll close the brackets, and we still have the negative 640 on the outside. The next step in our completing the square technique is to factor the first three terms here. So we have to think of two numbers that add up to negative 16 but multiply to positive 64. And that's going to be negative 8 and negative 8. So let's do that. So we're going to have x minus 8 squared. And we still have the negative 15 in front here. And we still have that negative 64 here. Oops. So before we can add our other like terms together, we just have to multiply this coefficient into this negative 64 here. So we're going to get negative 15 times negative 64, which in this case is going to be equal to 960. So P is going to be equal to negative 15 bracket x minus 8 squared. And when we multiply it, it's going to be positive 960. And then we have the 640 out here. And so we just have to add our like terms together now, and we'll be done. And we'll have our standard form into vertex form here. So 960 minus 640 gets me positive 320. So what is your X value that will maximize her profits? How many clients would she have to have per day? And that's going to be our H value right over here. So she needs 8 clients per day. Okay, so she needs 8 clients per day to maximize profit. So we can see, we can answer these questions that are in standard form to get the vertex in a much simpler way than having to factor, solve for the zeros, find the midpoint, H and K, and all that kind of stuff. So try out the homework and practice, 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 and you'll get this.